Today the weather is very fine, and I will put up my telescope. As you can see out here, it is a very fine weather. Hopefully it will stay clear through the night. I will always only set up the mount right now, and then I will also raise my tent if I can find it. It is hopefully in here somewhere, and when that is raised I will use that to cover the mount. So see you in a bit. So now I just went in to get a bite to eat, and now the mount is out, and I have aligned the stones, and I think it's sort of reasonably aligned. I have to realign it also in respect to north, so that it is pointing against the North Pole, the North Star. But now I'm going to raise a little tent that I use to put over the scope when I'm not using it. So let's do that. As you can see now, the mount is now in the tent. Hi and welcome to the observatory. My name is Michael Hansen, and right now you're sitting out here in the cold with me. As you can see here, we have a very bright star. It's a star that's called Dubhe. And in this video I'm going to try to give you sort of an idea of how I actually works a computer controlled telescope. So as you can see, I'm trying to move the star using my arrow keys down into the crosshair, as you can see here. It doesn't have to be perfect, but the better I do it, the more precise the tracking will be. Well, not actually the tracking, but So now I think I'm pretty satisfied with how it looks. So I'm going to go over here. As you can see in Maxim DL, I have a button down here that's called Sync. I'm going to stop the camera for now. It's called Sync, and it asks me what I want to do, and I want to sync my telescope with the position of Dubhe, and I'm going to do that.
Sync.
Now the computer, or actually EQSCOM, says sync, and as you can see here, if I go in here, you can see I have 1 point in my alignment, and if I open my alignment list, you can see I've synced to this position down here. Right? Alright, so let's try to select another star. Let's see what we can. We'll go into the telescope program here, and what can we choose? What shall we say? Let's say this position here. I'm going to do it in a slightly different way, because first I had Ursa Major here, which is the brightest star in the constellation Ursa. I can choose probably this star here, but I'm going to do it in a little. Yeah, I want to go in as few steps as possible. So let's take this star here instead. Oh, not as few steps, as much steps.
Slewing to target.
Let's go over here, and then it'll say slew complete.
Slew complete.
Yes, and we'll open EQSCOM again and start. Let's see how far off we are. Not that far off. Then we're going to center it to our best ability. The wrong direction. Yeah, you can see it's centered now. I'm sorry, it's a little hard to control the the phone camera and also control the computer here. But I think I'm satisfied right now. But instead of using sync here in Maxim DL, I'm going to go back to Carte du Ciel, or Carte du Ciel, Sky Charge, I think it means in English, and I'm going to say sync. Please confirm that the telescope is pointing at Beta Ursa Major, and I think it is. And then you can see if I go into my EQ mod again, I have 2 points. I have a point here and a point there. Now you can see it sort of tries to tell me where my points are. When I get more stars in, it'll make more sense. Alright, let's continue. So the next bright star we could choose could be in, let's see, what is this? This is also a part of Ursa Major. Yeah, let's take it. Mu, it's probably not as bright, but let's take it, see if we can find it. Slew.
Slewing to target.
And then we go into Maxim DL, open this, and see if we can find a bright star. Reasonable bright star.
Slew complete.
And as you can see, it seems pretty fair. It is here. Am I going to? Yes, I'm going in the wrong direction. Now I'm going to go after M81, which is relatively close to Ursa Major or Ursa Major, or whatever you want to call it. So I'm not going to take that many points, but the idea would then be to try to get points all over the sky. The problem is when you cross the meridian, the one you can see here, your points will be skewed, because then the telescope will shift position. It will have the weights on one side and then shift them over to the other side. But other than that, this is the main idea. I'm going to sync this. Want to make sure that I still have it selected. Yeah, so like that. Say sync, and please confirm. Yes.
Sync.
So that's the basic idea. I'm going to cut the video out here, and then I'm going to get back to you when I have synced all the stars I need. So see you in a bit. Right, welcome back. As you can see here, I actually changed my mind. I wanted to look at M42. M42 is sort of a nebula. You probably all know it as the Orion Nebula. So now we're going to say go to, like that.
Slewing to target.
Now my phone is almost out of power, so I might not make this recording as long, but I'm going to continue the recording when I get inside. So we can track the telescope.
Slew complete.
Yeah, no need to do that. Let's try to take a 30-second exposure just to make sure that we are on the right path. So as you can see, the exposure is running. Yeah. And then if I decide to go with Orion Nebula, I will decide how many seconds I want to expose and then go on from there. So let's see when the 30 seconds are up. Let's see what we get. As you can see, we are almost there. It seems okay. I can see part of the nebula. It's not quite on track, but let's just try to make a pinpoint to see if we can figure it out where this actually is. No, it doesn't seem like it. Yeah, I'm going to do something else. I'm going to go in here. I'm going to change this to local quadrant. Let's try to
Slewing to target.
make it slew to do.
Slew complete.
And let's try to take 30 seconds again and see what we get there. For some reason, the program I'm using to control the telescope, EQ mod or EQ ASCOM as it's also called, do have some problems figuring out where to point the telescope at certain times. So sometimes it's helpful to set it to local quadrant. Sometimes it's helpful to set it to peer side only. But it changes. There it is. There you can see the Orion Nebula. But I'm not completely satisfied, so let's put it at 1 second. Continuous. Like this. Now you see the central stars here. We're going to use them as our pointing tool and then try to get the Orion Nebula completely fixed in our point of view. I'm sort of going to get at it in 2 steps. Let's just get the crosshairs for like that, just to use them. Wrong way. I'm going to use the trapezium as it's called. You can see the central 4 stars in there. You probably can't see it's 4 stars now, but it is 4 stars. It's 4 very bright blue stars that are actually like that. And let's sync it. Sync to the catalog position. Yes.
Sync.
This might be a little bit off, because, but let's just keep it there and try to make a 30 seconds exposure. Crosshairs visible, off. Let's try to get this screen stretch window here up and set it at, let's see if we set it at high. That's not good. Set it at low. Yeah, let's say it like that. And let's get it at 100% so we can see it all. Let's stop it. And let's take a single, oh, you can see it here, a single 30 seconds exposure. And let it rip. So as you can see, it's counting up. Now, this is what my telescope actually sees. This is not fake. This is not something I'm figuring out or planning on, or what do you call it, making on my computer, CGI, anything like that. This is where my telescope is pointing at the moment, and I can go out and show you the actual telescope. I'll do that in a minute. Yeah, it's a bit. This is the Orion Nebula, but it's not that pretty because maybe a little wind blew on it. So I'm going to stop the video now, and then I'm going to go outside and show you my telescope, how it's actually set up. Now we are outside, and as you can see, here is the telescope. That was my shadow. This is how it looks. It's pointing at the Orion Nebula somewhere around up there. You can't see anything probably. So this is camera. I hope you can see anything. This is the opening. This is the actual telescope. This is how it looks. Now I'm going to go inside and continue the session. So see you in a bit. Bye bye. Now we are inside, and I just saw that my screen recording software Fraps actually can't record the desktop, which I hoped, because this is a Windows 10 machine. But in any case, you can see here that I have opened a TeamViewer session to my computer outside in the garage. And as you can see here, I'm running a series of 180-second exposures. The guider is running down here. And you can see two very large bumps here on the guider. This is actually because the program is doing something called dither. So in order to make sure that the noise that I get is not that important, the program moves the telescope just a tiny bit when needed. As you can see here, it moved a little bit. So if there are any hot pixels or any other kind of irritating noise on the sensor, it will not be in the same position with respect to the image itself. Furthermore, I'm trying to do something called a mosaic. As you probably know, you don't know, but as you could probably see, my telescope is actually not my telescope, and my sensor, my CCD, doesn't have a field large enough to encompass the entire Orion Nebula, so something will be missing. But by doing a mosaic, I can actually get the software to do this for me, and I find that very neat. Now, it might be that my positioning is not that good. I have to check that out and perhaps correct it in some ways. But in any case, oh, you can see there I had a pretty large bump. That might be a little blow from wind or something like that. But the RMS on both are actually pretty okay. So yeah, this is what I'm going to do most of the night, and then well, we'll see. I think I set the window size. I'm just going to try, sorry, my finger, just going to try to show you that. We're going to go to autosave, then mosaic. You can see I've set it to 15 by 15. Now the size of my sensor, just going to say cancel so that it doesn't screw anything up. The size of my sensor area, what I can see with my sensor, I think it's something like 20 arc minutes by 16 arc minutes. So if the correction, the direction of my setup here is not completely accurate, it should be okay. But yeah, this is what I'm going to do. And if anything really interesting happens, probably not, I'm going to get back to you. But tomorrow I guess what I'm going to do is to get this data here, what do you call it, reduced. So I have to take some bias images and I have to take some dark images. I'm going to see if I actually can get to see the other galaxy. Probably not. But on Friday there should also be a clear night, but we'll see about that. So yeah, thank you for watching, and see you in the next video. Bye bye.